Hey class, happy Thursday. I actually had to start this video over because I had to go back and solve these questions. So just know going into this last little bit, if these are super frustrating and super difficult, they are. They are harder than all the rest of them. So try your best. There's a few, I think if you look at it, you could figure them out. And if not, you're sticking with your letter of the day. But on that, you're going to be doing problems 49 through 54. Okay, 49 through 54. So pull out your ACT packet, pull out a calculator if you need one, pencil. And when you guys are all ready, sub, will you please pause this video once they're all ready and pull up Google a 6-minute timer. And once you push start, they will have 6 minutes to work on problems 49 through 54. When they are all done, you can come back to this video and I will go through these problems. All right, let's get to the answers. So we've got $49 is going to be B as in Bravo. 50 is J as in Juliet. 51 is C as in Charlie. 52 is F as in Foxtrot. 53 is A as in Alpha. And 54 is H as in Hotel. So mark those real quick. 49 is B. 50 is J. 51 is C. 52 is F. 53 is A. And 54 is H. Okay, these were hard. If you didn't get any of these right, you don't be too hard on yourself. These are not easy questions. Okay, this first graph. The graph of a function y equals f of x consists of 3 line segments. The graph and the coordinates of the endpoints of the 3 line segments are shown in the standard xy coordinate plane below. What is the area in square coordinate units of the region bounded by the graph of y equals f of x, the positive y-axis, and the positive x-axis? So you're trying to find the area of this shape. I recommend looking at it as 3 separate shapes. That's awful. Let me try again. So we've got this rectangle right here, okay? And then we've got a little triangle up here, and we've got a second triangle right there, okay? So if you look at this point 3, 3, that means the graph went right 3 and then up 3 to get to that point. So that is going to be the dimensions of this little square. Actually, I didn't draw it very well as a square, but it's 3 by 3. Okay, so if I want to find that area, it's just length times width. So 3 times 3 will be 9. Okay, and then I need to find the area of this top triangle and the bottom triangle. So if you look at this side on the graph, it's 0, 4. So if I go up 3 this far, I'm going to go 1 more to get up to 4. So this side right there is going to have a length of 1. And then right here, I've got the point 2, 3. That means I went right 2. That's going to be the length of the base. Okay? So the area for a triangle is just 1/2 base times height, or I like to write it as base times height divided by 2, which just gives me an area of 1 for that little triangle. Okay? And the last triangle, this point out here is at 5, 0, which means I've gone 3 plus 2 more. So that's going to be 2. And I already have the height as 3. So that one is also a triangle. So base times height divided by 2, 6 over 2 gives me 3. So if I add those all up, I've got 1 plus 9 plus 3 more gives me 13. Okay, so it's looking at each of those shapes individually, finding each area and then adding them up, and also having like an understanding of how to move from those points to get those different side lengths. All right, 50 is hard. This is the one that I had to start the video over because I did not get this one right the first time we did this ACT packet, and then even after I've done it a couple times, I had to remember how to solve it, and it's not easy. So if you're like, oh, my brain's just going to turn to mush and I don't really care, you can ignore me for a minute. If you're like, I'm really curious, I want to see how she does it, feel free to pay attention. Okay, the sum of two positive numbers is 151. I don't know what either of those numbers are. So x plus y equals 151. The lesser number, so I'm just going to designate this to be the lesser number, is 19 more than the square root of the greater number. What is the value of the greater number minus the lesser number? Okay, so the lesser number is x. So if I say the lesser number is 19 more than the square root of the greater number. Okay, that's my second equation. Okay, so from there, I wanted to get rid of the square root of y because it's really hard to plug it into the opposite equation as a square root. So I subtracted 19 from the second equation on both sides. And then I squared both sides to get rid of the square root. Now I do have to do the box on this left side. I did x minus 19 times x minus 19 to get x squared. I am going to go a little fast because honestly this problem is a lot. So if it's over your head, it's okay. If you're following, awesome. Okay. So I ended up getting x squared minus 38x plus 361 equals y. And then I took this and I plugged it in for y in the other equation. So I got x plus x squared minus 38x plus 361 equals 151. Okay? All right, and then I made it a quadratic. So I've got x squared. And then I've got minus 37x. And then I subtracted this over and got plus 210 equals 0. And, oh no, where'd it go? Okay, and then I had to factor that. So factors of 210 that add to negative 37, and I got negative 30 and negative 7. So I'm going to write this as x minus 30 and x minus 7, which tells me my answers are 30 or 7, okay? So going back to my two equations, I've got x plus y equals 151 and x equals 19 plus the square root of y. I plugged in 30 in for x here and said, okay, 30 plus y equals 151. What would that make the y value? And I got y would equal 121. And then I checked, does that work for the other equation? So if I plug in 30 here, 30, does that equal 19 plus the square root of 121? And I got, yep, sure does. Okay, so I got the x is 30 and y is 121. Okay, I checked with 7 to see if that works. So if I plug in 7 back into those equations instead, it doesn't work. 7 plus y equals 151. I get a y value of 144. Oh, maybe it does. I don't think it does though. So if I plug that into the second equation, does 7 equal 19 plus the square root of 144? And it does not. So the 7 just doesn't work. So those are my two values. The question says, what is the value of the greater number minus the lesser number? So if I take the greater number and I subtract the lesser number, I end up with 91. And that is your answer, J. That is a lot, okay? If you're thinking, what in the world? She went so fast and that made no sense. Don't even worry about it. Just guess on that one, your letter of the day, move on from there, okay? Don't even worry about that one. It's way too unnecessarily hard, but for anyone that wanted to understand, that's how you solve that one. Okay? All right. 51. The list of numbers 41, 35, 30, x, y, and 15 have a median of 25. The mode of the list of numbers is 15. To the nearest whole number, what is the mean of the list? If you guessed 27, you were so close. You were so close. Okay, so I did a couple things. The median is 25. At first, I guessed that one of the numbers is 25, but that's not right. So I'll show you why. But it does say that the mode is 15. That tells me the number that occurs the most is 15. So I could substitute in here, say 15 is one of the numbers. I'm going to write the rest of them out in order. So if I do 15, 15, x, 30, 35, and 41. it says the list of numbers has a median of 25. So I don't know what this value is, but that number plus 30 has to average out to 25. Okay, so I said, oh, that means it has to be 20, because if I add those together and I take their average, I get a median of 25. Because the median is always the middle number, but if there's an even number of values, it's the average of the middle two values. Okay. Okay, so those are all my numbers. It wants to find the mean, so I'm just adding all 6 of those numbers together, which, let me see what I got. 15 plus 15. Oops. 15 plus 15 plus 20 plus 30 plus 35 plus 41. And I get 156. And I'm going to divide that by 1, 2, 3, 4, 5, 6. I get 26 as my answer, which was C. Okay, so it was knowing that this would be the mode because it repeats, and then knowing that this had to be the average of the middle two numbers. Okay. Also, I know that this x had to be the other number that gave me the average, because any other two numbers wouldn't have given me a median of 25. So I knew that number had to go there. Okay. All right, 52. You are given the following system of equations: y equals x squared, rx plus sy equals t, where rs and t are integers. For which of the following will there be more than one solution with real number coordinates for the system? Okay, so this is asking about the determinant. We've talked about determinants. It's been a minute for sure. Actually, let me turn this. I don't know why I have it. Sorry, that's probably bigger. Determinants. So the determinant is just when you have a quadratic equation, we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Just the inside of the square root, that is the determinant, b squared minus 4ac. If you get a positive answer from that, that tells you there's two real solutions. If you get that it equals 0, that means it's one real double. We've covered this, it's been a minute. And if you get a negative, it means there's two imaginary solutions, okay? This one specifically says, for which of the following will there be more than one solution? Now, we don't even have numbers. That's the other thing here, okay? We've got two equations, but if I take x squared and I plug it in for y in the other equation, I can actually make a quadratic. Even though it's all letters, I can still make a quadratic out of this. So this is going to be my x squared term. This is my x term. And then I'm going to subtract this t over for my constant. Okay. This, even though it's a letter, is still my a value. This is my b value. And this is my constant. So if I'm plugging them into b squared minus 4ac, like I told you, the end of the ACT, guys, these are way harder than everything else, but we're still going to do it. So I got r squared, plug in for b, minus 4 times a, which is s, and c, which is negative t. If I simplify that, I get r squared. This negative and this negative are going to make it a positive 4st. That is the discriminant. Now, in addition to that, if you look at your answers, the first one is the only one that even makes sense. It's the only one that has r squared plus 4st. The rest of them do not. Also, I want to know when it is positive, because that's when I get two real solutions. So I want to know when this is greater than or equal to 0. Okay? I feel like if I was in class right now, I would see Brielle looking at me with that, like, what are you talking about face? So here's your shout out, Brielle. All right. 53. The third and fourth terms in an arithmetic sequence are 13 and 18, respectively. What is the 50th term of the sequence? I believe this was covered last year. We will be covering it later this year as well. So the arithmetic sequence a sub n is a1 plus n minus 1 times d. Okay. So when you have that arithmetic sequence, this is the first term in the sequence. This is what number you're trying to find, and this is the ratio that they are increasing by. So arithmetic means adding. So if this is the third term and this is the fourth term, I am adding 5 there. So if I want to find the first and second terms, I'm going to subtract 5 to get 8. And I'm going to subtract 5 again to get 3. So do you see if I did 3 plus 5, I'd get 8. 8 plus 5, I get 13. 13 plus 5, I get 18. So this is the first term. I had to find that. So AN equals the first term plus what number term am I trying to find? The 50th. And then the ratio that they were increasing by is 5. That doesn't change with arithmetic. It means I'm adding by the same number each time. So I'm going to have 3 plus, this is 49 times 5. And I ended up with, what did I end up with? 248, which is A. Okay, so this is the formula. Remember how I told you, I think yesterday, I said there's some formulas you might not be familiar with yet that you might want to write down that you could quickly review before you take the ACT to help you get one more question right. If you know that formula and how to plug into it, that's one more question, okay? All right, last one for today. One of the following graphs in standard xy coordinate plane is the graph of y equals sine squared x plus cosine squared x over the domain negative pi over 2 to pi over 2. Which one? This is one you just have to know. There's no solving about this one. Sine squared x plus cosine squared x by definition equals 1. So which one represents a graph where it just equals 1 the whole time? That would be H. So there's really no solving. It was just knowing the answer to that identity and knowing that if equals 1, it's just going to be a constant line for that graph. I believe you could graph this in the calculator. I'm actually curious if you type in sine squared x plus cosine squared x, what the graph would look like. We'll have to check it out on Monday when I get back, but I think it might give you just that straight line. Okay? All right, so I'm actually going to give you guys a 5-minute break because yeah, I'm going to give you a 5-minute break because that was a lot. 5 minutes, and then, so Seb, just give them a 5-minute break. Pause the video, please. They can get a drink of water or go grab a snack, go to the bathroom, walk around, talk for a second. 5 minutes. Go ahead and push play on the video again in 5 minutes. Thank you. Okay, pull out your 5.3 notes and homework. We're going to finish those today. And then if you don't get them completely finished today, that's okay, because tomorrow will be the last 6 questions of ACT, and then finishing, it's just going to be a work day. So if you don't get it all done today, you'll have Friday to finish as well. Okay, so we left off on inverses. I touched on them in both classes quickly. I know it wasn't enough time, and I know it's not enough to really comprehend them, but I just wanted to show you once so that when I come back here today to talk about it again, you've at least seen it. So I'm going to rewrite these equations right here. Y equals b to the x and log base b of y equals x. These are the same thing. You need to have these written down somewhere. You're going to use them for the homework a lot, okay? When you are finding inverses, so there's this note right here. It says, oops, right there. It says to find the inverse of a logarithmic function, switch x and y, change the exponential function, and solve for y. Okay, I'm adding something above that. I was writing it. To find the inverse, I want you to add this, of an exponential function. You're going to still switch x and y. Okay. Change to a logarithm, rather logarithmic function, and solve for y. It's the same steps, essentially. I'll give you a second to write it. So to find the inverse of an exponential function, switch x and y, change to a logarithmic function, and solve for y. So these are going to be your steps for finding the inverses. So if you notice, if you're finding the inverse of a log, you switch the x and y, change the exponential, solve for y. If you're finding the inverse of an exponential, you're switching x and y, change the logarithmic function, then solving for y. You're doing the same thing, but if it's an exponential, you're changing it to a log. If it's a log, you're changing it to exponential, okay? So we'll go through these two examples. All right, this one is in, exponential form. So if you look at A, to find the inverse of an exponential function, switch x and y. That's your first step. Let me give it a little higher. Okay. Then it says change to a logarithm. This is what I'm referencing for changing to a logarithm. It looks like this right now. It has x equals 6 to the y, and I want to change it to log base b of y equals x. I'm switching it to the opposite format. Okay, they are equal to each other. They're just different formats. So I'd start with log, and I'm going to write the base. Notice that the base is the same. It's the lower number in both forms. So base 6. Okay. And then the other thing I remember is if I'm going from one form to the other, if the base is by a y, it's going to be next to the x on the other form. If it was next to whatever value it's by in the one form, it's actually going to be equal to that in the other form, okay? So I'm going to change this to, log base 6 of x equals y. It's always going to be the opposite side. Okay, now then it says solve for y. This already is solved for y, so I am done. Okay, pull out your homework because I want to compare this to a couple problems in the homework so you can see what I'm talking about. Okay, so let's look at the homework. So we left off, you're supposed to get done through 27. If I look for one that's an exponential form, so like 29 is an exponential, 30, basically anyone that doesn't have a log as a part of the problem. Okay, those are all, not that one. Those are all in exponential form, okay? So I first switch x and y. That's my first step. Then I'm going to change it to logarithmic form. So if this was b to the x equals y, that's the same thing as, log base b of y equals x. Okay, that's what I'm going to be converting between. So you can label them if it helps you, but this is your base. So I'm going to do log base 7, and it's always the opposite side. Log base 7 of x equals the y. That's it. I'm done with that problem. It'll be the same thing for 30. 32 and 33 will have a little bit more, because if I do it for this one, let's do 32 together. I'm going to switch x and y. Okay. And then I'm going to change it to the log format. Sorry, I have two x's. That should be a y. Oh my gosh. Y plus 2. There we go. Okay, I'm going to change it to logarithmic form, so it's going to be log. This is still my base to the other one of x equals y plus 2. So first of all, when I switch it to log form, notice that I have log base e. Does anyone remember what that is called? You can flip back to the, second page of your notes or the back of the first page. Log base e of x, that is called ln. So ln of x equals y plus 2. There's nothing wrong with this. This is just, I guess I would call it more simplified. It's the correct form. And then I still have to solve for y. What else would I have to do to get y by itself? And we'll subtract 2 from both sides to get ln of x minus 2 equals y. So you're switching it from exponential form to log form, and then you are solving for y. Okay, there's those ones. I'll give you a second before I flip back to the notes. Okay, so then this one, I've got a log, and I'm trying to find its inverse, so read the second one. To find the inverse of a logarithmic function, switch x and y, change an exponential function, and then solve for y. So I'm going to start with changing x and y, switch their places. Okay. Then it says change to an exponential. So same thing. If I've got log base b of y equals x, I'm now trying to change it to b to the x equals y. So this one is not written in the right format because it has the ln right now, right? So ln is the same thing as log base e. I would definitely change it to that first before you try to change it to exponential, because if not, you don't have a base. You need that base to be able to change it to exponential. Okay, so I have the base now. It's e. It's always to the opposite side, no matter which form you're switching it to. E to the x is going to equal what's left, which is y plus 3. And then think, it says right there, solve for y. So I would subtract 3 from both sides to get y equals e to the x minus 3. Okay? So finish writing that one down. I'll show you a couple in the homework like that as well. Okay, so if I look at the ones that have logs now, so I'm gonna erase all this. Okay, so this one has a log, this one has a log, this one has ln. So just before you even do anything with this one, I'd change it to log base e before you change it, okay? And this one has a log. All right. So for those ones, I'm changing them to exponential form. So my first step when I'm finding an inverse, no matter which way, is to switch the x and y. And then I want to change to exponential, so I start with the base to the opposite side equals the last piece, y. Notice I dropped the log. That's on purpose. So when you're switching from logarithmic to exponential, you should not have log in your answer anymore. But y is by itself. I'm done. You're going to do the same thing for 31. You'll do the same thing for 34. Actually, let me go back on 34. I told you to do this first. I would actually, let's do that one together. I would switch my x and y first. Sorry. Just so you don't forget. Then write it as log base e. Okay. So I'm going to write it as exponential, so it's the base to the opposite side. E to the x equals y plus 1. And I need to get y by itself. So I would subtract 1 from both sides. Okay? All right, so that's how you're solving those. If it's in exponential form, you're rewriting it as a log. If it's in log form, you're rewriting it as an exponential. If you are struggling with these, I promise I will help you on Monday, okay? But just do your best. I want you to try, see what you can do. Okay, let's finish those notes. There are a bunch of log rules and some examples. I'm just going to show those to you real quick. So log base a of a equals 1. This was actually one of those rules up here. So if it was log base b of b, it equaled x. Same idea. This is equivalent to 1. So that equals 1. And so if you've got like log base 5 of 5, that equals 1. If you even have something like log of 10, what's that common base that we know? It's 10. So that would also equal 1, for example. Okay. If you have log base a of 1, it equals 0. So where this is coming from, if I write this in exponential form, it's a to the first equals a. Doesn't that make sense? Yeah. This one I'd write a to the 0 equals 1. Anything to the 0 does equal 1, so that works. So anything that's, where'd we go? We've got log of any number to the 1, it's just going to equal 0. You can also type these in on the calculator and it will show these to you. So if you're like, how am I supposed to know that? If you type log base 2 of 1 into the calculator, it would say equals 0. This one's super important. So ln of e is equal to 1. I want you to star that one. Anytime you have ln of e, those are inverses of each other, so it just equals 1. Okay, so, I mean, the example is the same thing. This is just ln of e equals 1. You do not have to have these memorized. The one I starred is the only one I expect you just like know. I'm just showing you what some of them are. Log base a of a to the x is just x. So this was the other one that we did up above. Log base 2 of 2 to the 4th would just be 4. These have explanations, but sometimes I think the explanation is more confusing. So I'm not going to do the explanation for this one. I just want you to know ln of e equals 1. This one is more obvious. A to the x would equal a to the x. That makes sense. And then as well as if I have ln of e to the x, because this equals 1, that would just equal x. Okay? So ln of e to a power would just equal whatever the power is. This one's huge. If you ever seen a problem, ln of e to the second, you would just cross that off and say, oh, it equals 2. So you do want to be able to do that one for sure. Okay, finish writing those down. We got one more page. So the one I started is the one I want you to know. There's one other one I'm going to show you as well. Feel free to pause this if people need more time. If not, I'm going to flip it over to the next page. Okay, so I've got a log of a to the x. This also equals 1. This is one of the identities we did yesterday on 22 through, let's see what problems. 22 through 27. This simplifies to just 1, so it's just x, because this would cancel out like that. Okay? So something like 4 log base 4 of 3, that would simplify to just give you 3. And the last one I want you to star, just like ln of e to the x equals x. The other way works the same. This is important. E to the ln of x, those cancel out as well and would equal just x. Okay, so you want to write that one down with a star. So this is equal to just x. Because they're inverses, it's like the same reason why if you do square root of x and then you square it, they cancel out. Same thing. E and ln, they're inverses, they cancel each other out. So you have e to the ln of 5. You would just go, oh, that just equals 5. Okay? All right, we've got graphing. Graphing logarithmic function. Whoa, graphing logarithmic functions. Remember that the graph of a logarithmic function is the inverse of exponentials. So I graphed this on the first page. I know some people didn't love it, that if the inverse or the exponential was right here, the logarithm would be here. Or if the logarithm exponential decay was like that, the logarithm would go like this, okay? We're just going to graph the logs on these ones. You don't have to worry about the exponential. It does have something to do with exponential though. So before you can graph these, you've got to rewrite it in exponential form. So if you look at it, here's a base. So we're doing b to the x equals y. We're converting it from log base b. Ooh, let me see if I wrote it that way on the other page. B to the x equals, where'd it go? Trying to find it. Yes. B to the x equals y, log base b of, okay, just making sure I'm being consistent. There's lots of ways to write this formula, so as long as you stick with the same variables in the right spots, I just want to make sure I wasn't flip-flopping on you, okay? So this is what I'm starting with, my log, and I'm going to change it to an exponential. You have to change it to an exponential to be able to graph these. So it's going to be 3 to the power of the other side equals x. That's what this log is the equivalent to as an exponential. Okay. And then you would just write a table, graph some points. So be careful because this is y and you're solving for x instead. So I'm going to plug in a value for y. So 3 to the 0, for example, 3 to the 0 You can type that in on the calculator. 3 to the 0 would just equal 1. That's my x value. Okay, I could try 3 to the first power. 3 to the first, so I plugged in a 1 for y, and I get 3. And I could plug in a 2. 3 to the second is 9. Okay, notice I'm plugging in the y value, and then I get an answer of an x value. Now I'm going to graph them. So 1, 0, 3, 1, and 9, 2. These graphs always, they have a vertical asymptote and they kind of go off like that, okay? So if it doesn't shift left or right at all, its asymptote should be at 0, just like that, okay? And then as far as its domain and range, again, all the exponentials had a domain of negative infinity to infinity. Because they're inverses of logs, their range will be from negative infinity to infinity. And then all of the ranges of exponentials were 0 to infinity. Because we're now flapped, if I look at the range, the first number I hit is 0, or close to 0, and then it keeps going off towards infinity. Okay, let's try another one like that. So first step, change it to exponential. So you could write that. First step, change the log to an exponential. Okay. So I would rewrite this one as 1/2 to the y equals x. When I change it to exponential, log should not be in it anymore. That's not considered exponential, okay? And then I'm going to make a table, and I'm going to graph a few points. So I do 0, and here 1/2 to the 0, anything to the 0, even a fraction, should just equal 1, okay? If I do 1/2 to the first, that's just 1/2, or 0.5. So be careful, because I'm plugging in for y. That's the y value. And I get my answer as terms of the x value, okay? If I do 1/2 to the second, again, this is my y value, I get 1/4, or 0.25, okay? And if you wanted, you could do some negative values for y to kind of figure it out, but this should be sufficient. If you graph it, it's 1, 0, it is 0.5 and 1, so right here, and then it's 0.25 and 2. So if you notice, this one is a decay. It's going, well, it's not a decay because it's log, but this one's going down, okay? And again, because it hasn't shifted left or right at all, it should have that asymptote right at 0. So again, our domain would be 0 to infinity, and our range would be negative infinity to infinity. So whether or not it's increasing or decreasing, as long as it hasn't shifted left or right at all, it's not going to affect the domain. Okay, I'll give you a second to finish writing. Okay, so you can graph a logarithmic function that has transformations too. So y equals log base b of x minus h plus k. So you guys tell me, this is going to do what to my graph? It's going to move it left or right. And this number at the end is going to move it up or down. Okay, so left or right. This is up or down. So you can graph a logarithm function of that form by translating the graph of its parent function. So this is the parent function, but then it can have some transformations. Okay, this one's going to be fun. So just like we ignored the transformations when we graph the logs, the exponentials, we're going to ignore the transformations when we graph the logs. So I want you to ignore these right now. Okay, other than the x. This x is important. We're going to change it to exponential. This is 2 to the y equals x. Okay? We're going to make a table. So if I plug in, for example, a 0 for y. Anything to 0, just 1. Okay? If you notice, 0, 1 is a very common ordered pair for these equations. They should be. it's part of it. 2 to the first, okay, I plugged in a 1, I get a 2. 2 to the second, I get a 4, so I plugged in a 2, and I got a 4. Let's do one more for fun. Let's do 2 to the third, and I get 8. Okay, so those are my ordered pairs. Then I'm going to go back and look at the transformations. Then I'm going to say, oh, it's shifted left 3, and it's shifted up 1. Okay, so I would graph your original points. You got 1, 0, you got 2, 1, you got 4, 2, and you got 8, 3. So here's your original graph. It's like right here. And then each point is shifting left 3 and up 1. So I'll take that point and go left 1, 2, 3, and up 1. Okay, I'll take this point and go left 1, 2, 3, and up 1. And I'll take this point and go left 1, 2, 3, and up 1. Last one, left 1, 2, 3, and up 1. However far left or right I shift it, this is going to be my vertical asymptote. So when you were doing exponentials, I really wanted you to pay attention to where that horizontal asymptote is. These ones, I want you to pay attention to the vertical asymptote. It is at -3 because it's shifted left 3. And this will be your graph. Okay. All right. Last thing, domain. It's shifted left 3. That's where my negative or my vertical asymptote is at. So it's from -3 to infinity because it gets really close to -3 without ever touching it. And my range is from -infinity to, goodness, infinity. Okay, you are done with the notes. You have the rest of class to work on the homework. Because I don't know how long this video is, I apologize. I don't know how long that is. But even if you run out of time to finish this today, you have the rest of Friday to get it done. And yes, I will be answering questions on Monday if you are still feeling super lost. Okay, I'm going to flip over to the homework. Look at those graph ones. So again, you're going to start with writing it as exponential. 4 to the y equals x. Come up with a table, graph it. It does want you to state domain and range. 1/3 to the y equals x. Come up with a table, graph it. Okay? Then when you start having transformations, ignore the transformation at first. Okay? Just change it to exponential. 2 to the y equals x. Figure out your table. And then go back and say, okay, wait. Oops, let's not do that. Then go back and say, oh, I'm going to take each of those points and shift them right 3 after you come up with the points. Okay? So like this one, I'm going to ignore the transformation and say this is 3 to the y equals x. Come up with my ordered pairs. Remember, you're plugging in for y first and then coming up with the x value. Once you find your points, then you go back and say, oh, and then I'm going to shift each of those points up 4. Okay? Even with the more complicated 2, there's only 2 that you have to do both. You're going to ignore these transformations and say, okay, this is, oh, one more thing. Do you see how this one has y of it, or f of x? So I would rewrite this one from the beginning as y equals log base 4 of x plus 2. Okay, so change it to y equals. So I'm going to ignore these transformations and change it to 4 to the y equals x. If you look at these guys, if you're feeling super lost, they're all the same format. It's a number to y equals x. That's the common theme. So like this one, 6 to the y is going to equal x. Every single one of them. It's a number to the y equals x when you change it to exponential format. Okay, then you're going to go back and look at the transformations once you come up with your ordered pairs and say, oh, wait, I'm going left 2, and I'm going down 1 in each of these points. Okay? All right, do your best. Write your domain and range. All of the ranges should be negative infinity to infinity. And I will see you guys on Monday. Have a wonderful day.